Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. Took way longer to produce this thing than I had counted on, so I'm actually recording this about 10 o'clock. Most of you are probably either in bed or on your way to bed, so the nice thing about these bonus videos is that they're up, all the time, and so you don't have to watch it necessarily on the day that it was recorded. You can watch it anytime that you please. So the topic for today is ways that the National Weather Service serves the state of North Carolina, and it may surprise you how many different entities have to come together to do that. And then I wanted to do a little bit of a commentary on television station radars. Do they really serve a purpose, or is it all promotional value, or is it some of both? And having worked in the television industry for just shy of 40 years and having had a couple of radars at the TV station that I worked at, I can definitely give you some insight into that. So let's go on ahead and start off with the National Weather Service responsibilities and how they serve the state of North Carolina. And so it turns out back in the 80s, when I first arrived in North Carolina, the National Weather Service Forecast Office in Raleigh was responsible for all 100 counties in North Carolina. So they had to provide forecasts for Murphy and Boone and Greensboro and Charlotte and Raleigh and Wilmington and Cape Hatteras and Elizabeth City. They were responsible for the whole state. And then when the National Weather Service modernized in the late 80s and 90s and they rolled out their network of Doppler radars, then they adopted a different philosophy, which really made a whole lot more sense, is that why not have the National Weather Service forecast offices near all of these radars, which are strategically spaced so that we can get the maximum coverage from those radars. And then each Weather Service forecast office would use the radar, which would effectively cover the area that they were responsible for. So there are actually 7 National Weather Service offices that serve the state of North Carolina. And the one that you're looking at here that takes care of the 2 most extreme southwestern counties of North Carolina around Murphy is the National Weather Service office located in Morristown, Tennessee. So they're responsible for any warnings and forecasts that are issued for those 2 counties. Then, as we move on ahead to the next area, this area is served by the National Weather Service office out of Greenville-Spartanburg, South Carolina. And so they cover, Mount Mitchell and Grandfather Mountain and Asheville and all the way over towards Charlotte and up to just southwest of Greensboro and Winston-Salem. And so that entire chunk of real estate, again, all the warnings and all the forecasts are issued by the office in Greenville-Spartanburg. Then the office in Blacksburg, Virginia, up near Roanoke, or not too far from Roanoke, is responsible for the northern mountains of North Carolina, the northern foothills, and portions of the northwest Piedmont. So that would include Boone, West Jefferson, Wilkesboro, and as far east as Yanceyville in Caswell County, okay? Then, if we take a look at the next area, the Raleigh, North Carolina National Weather Service office really covers most of what you can call the WRAL, or the Raleigh-Durham television market viewing area, and it extends from Roxborough all the way to Roanoke Rapids and Halifax, as far east as Tarboro, Wilson, Goldsboro, Clinton, Fayetteville, Rayford, down to Laurinburg, and then up to Southern Pines and Asheboro and Greensboro and Winston-Salem. So all of those areas are covered by the Raleigh office of the National Weather Service, which is located on Centennial campus at NC State. Then Wakefield, Virginia takes care of the extreme northeastern part of North Carolina, and that includes Northampton County, which I don't know if it's still in the Raleigh-Durham television market, but it was at least off and on, and that included, for instance, the town of Jackson. And so you were getting your warnings from a different National Weather Service office than the rest of the viewing area in central North Carolina. So now we're up to 5, okay? Number 6 is the National Weather Service office at Newport and Morehead City, and they cover the area around Greenville, so East Carolina would be underneath the jurisdiction of that, down toward Kinston, and also Kenansville in Duplin County, and also Jacksonville and Morehead City and Atlantic Beach and and the Outer Banks, and so, or at least most of the Outer Banks. So that's the responsibility of the Newport and Morehead City office. And then finally, the Wilmington office takes care of the southeastern corner of North Carolina, and that includes areas like Lumberton and Elizabethtown and into Pender County, Columbus County, Brunswick County, New Hanover County, around Wilmington, and Carolina Beach and places like that. So 7 different National Weather Service offices combine efforts, and they're at least supposed to do this, and I think they do most of the time. They coordinate, because if they all operated completely independently and you lived on the border between one office and another, there might be a different opinion on the forecast. And so you don't want somebody that lives 2 miles over the Sampson County line getting a different forecast than somebody that lives 2 miles over the Bladen County line, okay? So they are supposed to coordinate their forecast to make sure that there's no major differences occurring across these different boundaries. Now, let's take a look or talk about radars at TV stations, because there was a time when it really was an advantage to have one of these, and I'll try to explain why here. Now, radar has limitations with distance, okay? The radar beam at the National Weather Service, they have what they call a volume scan strategy, where they shoot the beam out at a very low angle and they spin it around, and then they turn it up a little bit and spin it around again and turn it up a little bit and spin it around again. So over a period of 5 or 6 minutes, you get a complete or almost a complete volume scan of the atmosphere overhead, okay? There is what we call a cone of silence, where the radar can only go up so high, and so there's always an area directly over top of the radars where you can't see what's going on, and that's why you look at surrounding radars which don't have that issue, and they can see clearly as to what's going on top of the radar at another location. But anyways, you can see here that 10 miles away from the radar, the center of the beam width, okay, so it's not a line, it's like a beam that spreads out as it goes away from the radar. So the beam height's only 240 feet at 10 miles, and part of the beam actually bangs into the ground, which is why you have a ground clutter pattern on the lowest elevation right near the radar. And the beam width, the width of the beam, is only 860 feet. So it can resolve a lot of detail very, very close into the radar, and this is why within 10 or 20 or 30 miles, tornadoes are much more easier to detect using radar than they are once you get farther away, because the beam is getting wider and it's also getting higher because the Earth is curved, okay? The Earth is curving away, the radar beam's going up, and so the distance of that beam above the ground continues to increase. At 50 miles, the center of the beam height is over 2,000 feet above the ground, which is still not too bad, but the beam width, instead of being 860 feet, is now over 4,000 feet. And by the time you get to 100 miles out, the center of the beam is over 7,000 feet high, and the beam width is over 8,000 feet wide. So that's why, for instance, if you were using the Raleigh radar from the National Weather Service to take a look at the weather down around Riceville Beach or Wilmington, and you were going to be issuing warnings based on that, that wouldn't be a real good idea, and that's why they have the radar down in the Wilmington area to look at Riceville Beach, because the beam elevation and the beam width is much, much smaller because it's much, much closer. Those towns are much, much closer to the radar. Okay, so now, in terms of local TV station radars, here's the radar in the lower right-hand portion of your screen, and we're going to hypothetically say there are 2 thunderstorms. One's closer to the radar and another one is farther away. Well, the TV station radar sends out a beam, and a whole bunch of that beam, or at least a significant portion of it, gets eaten up by that first thunderstorm. And so the amount of radiation that gets through that storm and can penetrate to the second one is greatly reduced. And so it bounces off that second storm in a much, much weakened state, and by the time the beam gets all the way back to the radar, then you're not really seeing that second thunderstorm for whatever intensity it has. Now, television station radars are what we call C-band radars, which have a wavelength of 5 centimeters, and it's simply a physical principle of a 5 centimeter wavelength radar that more of the signal is going to attenuate or get blocked by the first object, not allowing much of that signal to get off to the second one. And so there were times I can remember saying on the air that, hey, we're seeing very weak activity out here at a distance, but if we take a look at the National Weather Service radar, you can see that it's much, much more intense than that. And so we never looked, or at least I didn't, as our radar competing with the National Weather Service. It's supplemented an already great radar. I mean, the National Weather Service radars are the Cadillacs of all Doppler radars, and the TV station radars simply help to supplement that information. Okay, so now the National Weather Service radar is what we call an S-band radar, which has a wavelength of 10 centimeters, and much, much more of the signal can get through that first one, get to the second thunderstorm, and give us a much, much more accurate idea as to how intense that second storm is. And again, that's simply a physical principle of the different wavelengths. And I think this is still the case. TV stations are not even allowed, so far as I know, to purchase S-band radars, and the concern was that if they did, there would be the potential for interference with the National Weather Service radars. And so that's why the TV station radars were 5 centimeters and the National Weather Service radars were 10. Okay, now, last point I wanted to make here is that things have changed significantly over the years. Back in the 90s, the lowest tilt elevation of the National Weather Service radar only updated every 6 minutes because it took that long to spin around at the lowest elevation, tilt up, spin around again, tilt up, spin around again, and get all the way up to the top, okay? So the problem with that is that if you were doing street level mapping and you had a tornado moving at 60 miles per hour and you showed an image that was 6 minutes old, that means the location you were showing of that tornado was 6 miles off, okay? That's not good, especially when people's lives are in danger, okay? So in that case, the television station radar wasn't doing that volume scan and taking 6 minutes to do the complete cycle. It could simply send that beam out and get a continuous reading. I mean, if you wanted to, you could simply aim the radar beam at the thunderstorm you were concerned about and never move it and get updates literally every second as to what that storm looked like. Or if you wanted to spin it around, you were still getting an update maybe every minute, whereas with the Weather Service radar, you were only getting every 6 minutes. So that was a decided advantage. But things have changed since then. The National Weather Service now has a volume scan strategy where the lowest tilt elevation updates every 75 to 90 seconds now, as opposed to every 6 minutes. So the advantage of having your own radar at a TV station is not nearly what it was because of the fact that the National Weather Service has changed their scan strategy and they update that lowest tilt elevation about every 75 to 90 seconds during severe weather. Now, there is still a situation, though, where the television station radar can play a huge role, and Charlotte in North Carolina is a great example of this. Charlotte, as you all know, is the most populous city in North Carolina, but it doesn't have a National Weather Service Doppler radar any closer than 50 miles to it, and that's the one at the Greenville-Spartanburg National Weather Service office. So by the time the beam gets over Charlotte, it's, not real high, but it's high enough so that there can be, you could miss some things underneath the beam. So there's been an effort afoot to fill in that hole, and the television stations in Charlotte that have their own radar provide a significant service there because they're helping to sort of fill in the holes in between all the National Weather Service radars. Now, the fortunate thing in the Raleigh-Durham area is that the television station radars and the National Weather Service radar are within a couple of miles of each other, okay? So you don't have that issue of filling in holes like you do around Charlotte, where you don't have a National Weather Service radar that close. And one of the things that I loved about the fact that our radar at the TV station was so close to the National Weather Service radar is that we can, in a sense, calibrate our radar and say, okay, if we're seeing something significantly different than the Weather Service radar is, then we want to take a look at how the radar is calibrated and what our settings are and all that type of thing. So that was a great tool to have their radar that close to ours so that we could compare notes and make sure that we were seeing the same thing that they were seeing. So overall, my personal opinion is that the value of a television station radar is not as great now as it used to be, because the Weather Service radar updates that lowest tilt much more frequently than they used to. But if you wanted to, if there was only one big storm that you were concerned about, the television station radar can still just aim the beam at that storm continuously and get a second-by-second update, which is still going to be better than waiting perhaps 75 to 90 seconds for the National Weather Service radar to spin around and give you another reading at that lowest elevation. So it's a hodgepodge back and forth. And of course, I know there are people out there that are going to say, oh, it really doesn't have any benefit at all. It's just for promotional purposes so they can beat their chest and say they have their own radar. And there's some truth to some of that in some cases. But there are legitimate things that these TV stations can add. And again, they're not competing. They can't compete with the National Weather Service radars. They're not as good, just period. But they can supplement the National Weather Service radars with some pretty good information from time to time. And so they really do serve a purpose. All right, folks, that's it for now. That's bonus weather video number 1 for this week. Hope you found that at least mildly interesting. The next daily weather update coming up tomorrow, and the next bonus weather video coming up tomorrow as well. So hope you'll join me for both of those. In the meantime, if you're still up, have a great rest of your Tuesday evening, and we'll talk to you again tomorrow. Take care.